Hi viewers, welcome to all. Here we are discussing about a project design of approximate restoring divider. Here approximate computing is an emerging paradigm in error-tolerant applications that leads to power-efficient design without significant loss in quality. That's divider in these applications have complex hardware and more latency among the computational blocks, resulting in power consumptions. Here approximating the division model would lead to designs with a vastly improved power efficiency. A new approximate subtractor is proposed in this paper with the intent to reduce the hardware complexity while achieving accuracy within permissible limits. Okay, the proposed AX subtractor, that means the approximate subtractors, and existing approximate subtractors unit are used in the restoring array division architecture to prove the efficiency of the approximate subtractor. The proposed architecture is designed with the 8x4 approximate divider using Verilog HDL and synthesized using Xilinx Spartan 6 FPGA and proved the performance of area, delay and power. Now we can verify the project. Okay, so here this project we are fully focused for the approximate restoring divider. For reference, we have used this reference paper, approximate restoring divider, using inexact cells and estimation from partial remainders. Okay, so here they have used this architecture, the figure 1 architectures. So it will be constructed using the exact restoring divider cell. Okay, so figure 2a. Okay, so this block it will be constructed with the full subtractor. That full subtractor also it will be generated with the two half subtractors based architecture, that is a conventional full subtractor designs. Okay, and after we'll use the multiplexers. Okay, so this architectures will take more logic gates. Okay, instead of this logic gate we need to reduce number of logic gates, and also we will get an approximate value in the divider. Okay, why? Because approximate is mostly enough for signal processing and image processing applications. Okay, to reduce the number of logic gates we are planned this proposed architectures in approximate level. Okay, so here figure 2b, the proposed approximate restoring divider AxSUB cell we have developed it. Okay, so that will be developed with only one XOR gate and one NOT gate. Okay, this cell we have used in the architecture of 8x4 exact restoring divider. Okay, so we have developed two different architectures. One is a AxSUB model, another one is a AxSUB model. So here this AxSUB model we have developed a AxSUB M1 architecture. Okay, so this architecture code we have developed in a Verilog HDL. So this is the existing model of AxSUB and this is a proposed model of AxSUB. Okay, and we have simulated this code in modelism. Okay, so here you can check divide and divisor, quotients and remainder, and the divisor cell. Okay, and the proposed architectures. Okay, so here you can check divide and divisor, quotients and remainder, and divide and the AxSUB divider cell. Okay, so, and this code we have synthesized in Spartan 6 LX9 FPGA. Okay, so here you can analyze the number of slice registers, number of LUTs, occupied slices, IO base. Okay, and synthesis report you can check delay. So this is for AxSUB model. Okay, and RTL schematic we can check AxSUB divider cell. Okay, so this is a AxSUB divider cell 8x4 architecture. Okay, and the proposed method you can check the comparisons, the number of LUTs and occupied slices, and synthesis report you can check delay. Okay, 17.381 nanosecond, and RTL schematic you can check the AxSUB divider cell. Okay, after this we have written our comparisons for this two model. Okay, so this is a comparisons table and comparison chart. Okay, and we have written an abstract document for this project, proposed abstract, exact restoring divider cell. Okay, so and approximate restoring divider cell, advantages, disadvantages, software implementations and related notes for this project we have used. Finally come up with the literature survey and references. Okay, thank you.
If you need more video related to VLSI project, please like and subscribe this channel.